physical parameter able to influence the rate of reaction and which modifies the evolution time of the system. To know this, we did firstly experiment with oxalic acid and permanganate potassium.
Temperature experiment, we need 2 beakers with 3 ml of the potassium permanganate solution with a concentration of 5 times 10 to the power of -3 mol by liter. We put one of those beakers in an hot bath and we add 10 ml of a solution of oxalic acid with a concentration of 1 times 10 to the power of -1 mol by liter, and at the same time we add oxalic acid solution. We start the chronometer and we stop this one when the reaction is finished, when the solution is totally transparent. We can see that this reaction is quicker than this one.
But why? It's because when the temperature increases like here, in reality, particles agitation increase too, and like this, they collide more, so the reaction is faster.
I'm going to talk about the study of the region's concentration influence in a reaction. So we have 2 reactions. Reaction will take place in a hot bath because we want the reaction to be seen with the eyes and we don't want to wait. And we see before in the temperature experiment that when we don't put the reaction in the hot bath, it was really very long. We are going to do an experiment to see if the concentration of the reagent is the kinetic factor. At the end of the reaction, you can see that the one with the higher concentration is the one who reacts faster, and the one with the reagent less concentrated is a lot more slow. To understand this result, I'm going to draw parallel with a room with a certain amount of boys and girls. And if you take the same room with more boys, for example, it will take less time to react because there is more people. But we have the same thing if the room is smaller and decrease the size.
We would like to know if the solvent has an influence on the reaction rate. In order to study this influence, we dilute a 5 times 10 at the power of -3 mol per liter solution of permanganate solution to make 2 5 times 10 at the power of -4 solution of permanganate potassium, one with water as solvent and one with acetone. We put 2 beakers of 3 ml of each solution in a hot bath and we pour at the same time 10 ml of oxalic acid in each beaker and start the timer. We could see that the reaction with acetone reacts faster than the reaction with water. So we know that solvent has an influence on the reaction time, and I will try to explain why. Acetone is an aprotic solvent. It means that it couldn't lose proton or make hydrogen bond, contrary to water, which is a protic solvent, which could easily make an hydrogen bond. Potassium permanganate is an anion, and when an anion has hydrogen bond, it is more difficult for it to react with other reagents. So the reaction between oxalic acid and permanganate potassium is slowed when the solvent is water. We can conclude that solvent is a kinetic factor, and it could be used in order to slow or accelerate a reaction in different cases.
A catalyst is the species that accelerate a chemical reaction without being consumed. And to show the action of catalysts, we conducted different experiments. Hydrogen peroxide catalyst is heterogeneous. After putting the wire in the oxygenated water, we see bubbles showing a release of O2, which we do not observe without catalyst. We know that hydrogen peroxide breaks down into H2O and O2, but that goes very, very slowly. We can say that the reaction is accelerated by the presence of potassium. time the ions are homogeneous catalysts, here there is a gas release and a change in the color of the solution. The color change of the solution indicates the Fe3+ ions participate in the reaction and are regenerated at the end of the reaction because they return to the original color of the reaction. Finally, we experimented with turnip, which is an enzymatic catalyst. So here we obtain a gas release, which proves there is a formation of O2. Indeed, each enzyme has an active site into which the molecule that react on the enzyme enters. To the control tube, where nothing happens, we see that the three catalysts accelerate the reaction. They increase the speed of the reaction, or decrease its duration. To conclude, the parameters that we can change to improve their action are the surface area for platinum wire and the concentration for ions. The greater its concentration, the greater the more efficient the catalyst.